Hello friends, first of all welcome of all of you in this video lecture series of 12th Commerce Economics. So far up to this video lecture we covered first topic, second topic, then 3A demand analysis, and we start the second part of third topic, that is 3B elasticity of demand. In elasticity of demand we covered types of elasticity of demand, concept of elasticity of demand, definition of elasticity of demand, introductory part of elasticity of demand, and then we start methods of measuring elasticity of demand. There are three methods of measuring elasticity of demand. First is ratio or percentage method, second is total expenditure method, and third is point method or geometric method. In previous lecture we covered ratio or percentage method. So the next method is total expenditure method. Expenditure, that is expenses, outlay, how much money you spend on your consumption expenditure or in total expenditure, all over expenditure. This method was developed by Professor Marshall. In this method the total amount of expenditure before and after the price change is compared. In this method total amount of expenditure before and after the price change is compared. Here the total expenditure refers to the product of price, the price of product and quantity demanded. So total expenditure is equal to total expenditure is equal to, or total outlay or expenditure is same, total outlay and expenditure is same, outlay means also expenditure, is equal to price and quantity demanded, price into quantity demanded, that is total outlay or total expenditure. Under this method elasticity is measured by observing the changes in outlay in response to changes in price. Under this method elasticity is measured by observing the changes in outlay or changes in expenditure in response to changes in price. So in this table there are 5 columns. The first serial number or case A, B, C. A second column shows price per unit in rupees, 10 rupees, 20 rupees, 30 rupees, 40 rupees, 50 rupees and 60 rupees. Third column shows quantity demanded, 6 units, 5 units, 4 units, 3 units, 2 units and 1 units. Total outlay, how to calculate total outlay or total expenditure? Price into quantity demanded, 60, 10 into 6, 60, 20 into 500, 30 into 4, 120, 40 into 3, 120, 50 into 2, 100 and 60 into 1, 60. And next elasticity of demand, relatively elastic, unitary elastic, and relatively inelastic. So start explanation of the given table. In case A, or serial number A, original price is rupees 10 per unit. Original price is rupees 10 per unit, and quantity demanded is 6 units. Quantity demanded is 6 units. Therefore, total expenditure incurred, or total expenditure, is rupees 60. When price rises from rupees 10 to rupees 20, quantity demanded falls to 5 units. The total expenditure incurred is rupees 100. In this case, total outlay or total expenditure is greater than original expenditure or original outlay. Hence, in this example, elasticity of demand is greater than 1. Elasticity of demand is greater than 1, that is relatively elastic demand. Relatively elastic demand. So in this diagram we show relatively elastic demand curve. Original price is P, at the same time quantity demanded is Q. Due to a small change in price brings about a relatively higher quantity is demanded, so it is known as relatively elastic demand, or elasticity of demand is greater than 1. So this is the diagram which shows or explain in graphically the first case, that is case A. In example B, or serial number B, original price is 30 per unit and quantity demanded is 4 units. So the total expenditure is rupees 120. When price rises to rupees 40 and quantity demanded falls to 3 units, quantity demanded falls to rupees 3 units, total expenditure incurred is also 120. Means in both the cases, when in case B, when price is rises from 30 to 40, total outlay or total expenditure is same. Total outlay or total expenditure is same. In this case, total outlay is same or equal to original expenditure. Original expenditure is also 120. And when rise in price from 30 to 40, quantity demanded is 3 units. At the same time, total outlay is also 120. So elasticity of demand is equal to 1. That is, elasticity of demand is ED, or elasticity of demand is equal to 1. That is unitary elastic demand. Unitary elastic demand. Unitary elastic demand unitary elastic demand It shows unitary elastic demand. This diagram shows unitary elastic demand. In next case, C, original price is 50. At the same time, quantity demanded is 2 units. Therefore, total expenditure is 100. When price rises to rupees 60, 50 to 60, that is 10 rupees rise in the price per unit. Quantity demanded falls to 1 unit from 2 unit, and total expenditure incurred is 60. In this case, total outlay is less than original expenditure. Total outlay or total outlay is less than original expenditure. Hence, elasticity of demand is less than 1. Elasticity of demand is less than 1, or elasticity is less than 1. This is relatively inelastic demand. This is relatively inelastic demand. This is relatively inelastic demand. In such case, the demand curve is steeper slope. The demand curve is steeper slope. In case B, that is unitary elastic demand, demand curve is rectangular hyperbola, and in case A, relatively elastic demand, demand curve is flatter slope. Demand curve is flatter slope. So this is total expenditure method or total outlay method. Next method is point method or geometric method. Professor Marshall has developed another method to measure elasticity of demand, which is known as point method or geometric method. The ratio method and total outlay method are unable to measure elasticity of demand at a given point on the demand curve. This is very important thing as far as our point method or geometric method is concerned. The ratio method and total outlay method are unable. Ratio method and total outlay method are unable to show or unable to measure elasticity of demand at a given point on the demand curve, or on the given same demand curve. Means in percentage method or ratio method, and in total outlay method or total expenditure method, only percentage is calculated, and only in second method only the elasticity is calculated on the basis of outlay or expenditure. But exactly in a given demand curve at a specific point, what is the elasticity of demand at that given specific point does not measure. That's why Professor Marshall define or explain another method of measuring elasticity of demand, that is point method or geometric method. At any point on the demand curve, elasticity of demand is measured with the help of following formula. So point elasticity of demand or geometric elasticity of demand is equal to lower segment of the demand curve below a given point divided by upper segment of demand curve above a given point, that is u. So demand curve may be either linear or non-linear as shown below. So in point method or geometric method, to calculate elasticity of demand, we use the given point on the same demand curve, that is the given point may be lower segment of the demand curve below a given point divided by upper segment of demand curve above a given point, that is L upon U. But in such case, the demand curve may be either linear or non-linear. The demand curve may be either linear or non-linear. Here I explain you both methods, that is linear and non-linear. So this is the linear demand curve. In actual, demand curve is not touched to any axis, but for this method, to explain this method, when the demand curve is linear or a straight line, we extend the demand curve to meet the y-axis at point A and up to x-axis at point B. So the price elasticity of demand at x-axis is 0. Price elasticity of demand at x-axis is 0 and at y-axis is infinite. So elasticity of demand will be different at each point. Let us assume that AB is a demand curve. AB is a demand curve. AB is a demand curve. AB is a demand curve and its length is 8 centimeter. Its length is 8 centimeter. The total length of AB demand curve is 8 centimeter. Point elasticity at various points on a linear demand curve can be measured as follows. At point P means this point. At point P means this point. So what is our formula? Our formula is PB divided by PA. So length of PB is 4 centimeter and length of PA is also 4 centimeter. So 4 upon 4, 1. So the elasticity of demand is unitary, that is unitary elastic demand. In next case, at point P1, at point P1 means this point. At point P1 point elasticity of demand is measured as P is equal to P1B divided by P1A. So length of P1B is 2 and P1A, that is 2, 4, 6. So 2 upon 6 is equal to 0.33. So elasticity of demand is inelastic, that is less than 1. In next case, elasticity of demand at point P2, that is this point P2 or price 2, P2 is equal to, so how to calculate P2 or elasticity of demand at point P2? P2B, P2 P2B divided by P2A so 6 upon 4. The length of P2B is 6. How it is 6? टू प्लस टू 6 आणि हा जो डिस्टन्स आहे P2 to y axis or point A, that is 2. So this distance is equal to 3. 6 upon 2, 3. So elasticity of demand at point P2 is greater than 1, and at the point P2 elasticity of demand is relatively elastic, that is elasticity of demand is greater than 1. At point A, elasticity of demand at point A, the point elasticity is because of upper segment is 0, perfectly elastic demand. Upper segment is 0, that's why it is a perfectly elastic demand. And at point B, the elasticity is 0 because lower segment is 0. That's why it is perfectly inelastic demand. In other words, linear demand curve, when the demand curve is linear straight line, we extend the demand curve to meet y axis at point A and x axis at point B. Price elasticity of demand at x axis is 0 and y axis is infinite. Why it is so, we see in this lecture. Elasticity of demand will be different at each point. Let us assume that AB is demand curve and its length is 8 centimeter. That is, the length of this AB, is 8 centimeter, means this distance is 2 centimeter. 2 plus 2 plus 2 plus 2, 2, 4, 6 and 8. So at point P means this point, at point P means this point, elasticity is measured as PB. Formula is L upon U, lower segment divided by upper segment, PB. So the PB 2 plus 2, 4 divided by PA, that is this portion, 2 plus 2, 4. So the elasticity is equal to 1. Thus at point P, elasticity is unitary elastic, that is elasticity of demand is equal to 1. Next, at point P1, the elasticity is measured as P1 is equal to P1B. P1B means this portion, that is 2, and P1A, that is upper segment, means 2 plus 2 plus 2, 6. So elasticity is equal to 2 upon 6, 0.33, 0.33. Thus at point P1, demand is relatively inelastic, or elasticity of demand is inelastic. Next, in case third, at point P2 means this point, at point P2 in this point, the point elasticity is measured as P2 is equal to P2B. P2B means this portion, P2B 2 plus 2 plus 2 is equal to 6 divided by P2A, this portion 2. So 6 upon 2 is equal to 3. So elasticity is greater than 1, or relatively elastic. So at point A, the point elasticity is infinite because upper segment is 0. Upper segment is 0, so it is perfectly elastic demand. And at case fifth, at point B, the point elasticity is 0 because lower segment is 0, that is perfectly inelastic demand. This is linear demand curve and measurement as per point or geometric method. So the next, non-linear demand curve. Non-linear demand curve, when the demand curve is non-linear, that is एका सरळ रेषेमध्ये नाही, कर्व दिला आहे, convex to the origin, the measure price elasticity of demand, we have to draw a tangent sparshika at AB touching the given point on the demand curve and extend it to meet y-axis at point A and x-axis at point B. So how to calculate demand curve as per non-linear demand? When demand curve is non-linear, elasticity of demand is equal to lower segment of the tangent below a given point, that is L, divided by upper segment of the tangent above a given point, that is U. So in this diagram, price is given on y-axis, quantity demanded is given on x-axis. TR is the demand curve, and TR is the tangent, or AB is the tangent in this diagram. AB is the tangent, and in this diagram point S shows the point at which point S and point E. At point E and at point S on both the diagram, demand curve is convex to origin to measure the price elasticity. So in this diagram, in which AB is the tangent, and at point E, DD is the demand curve, P is the price, and Q is the quantity demanded. If EB, that is this point, EB is equal to EA, EB is equal to EA, ED is equal to 1, that is elasticity of demand is equal to 1, that is unitary elastic demand. And if EB is greater than EA, if EB is greater than EA, then elasticity of demand is greater than 1, that is relatively elastic demand. And if EB is less than EA, elasticity of demand is less than 1, that is relatively inelastic demand. So this is non-linear demand curve in which one tangent is drawn which touches y and x axis, and at point E the DD is the demand curve is given, and if P is the price and Q is the quantity which is shown as per in this diagram. So EB is equal to EA, unitary elastic demand, EB is greater than EA, relatively elastic demand, and EB is less than EA, relatively inelastic demand. Thanks for watching. After watching this video, you have to write down methods of measuring elasticity of demand in detail, all three methods.